did yesterday, we started talking about the nitty-gritty of parabolas. We spoke about the focus and the directrix. We said basically every point on the parabola is an equal distance from the focal point and the line, the directrix line. We also talked about the latus rectum, and remember the latus rectum is a segment whose endpoints are on the parabola that is perpendicular to the axis of symmetry, and it goes through the focal point. So those were the three things we talked about at the end of last class. Okay. Did we talk about the equations of the vertical parabola versus the horizontal parabola? I believe we did do that. Yes? X equals a times the quantity of y minus k squared plus h is the horizontal parabola. We did. Yep, the k and h's are swapped. So we spoke about all that. All right, things to memorize. So this is where we're starting. So we're continuing day 2 now. Things to memorize. Are you guys impressed that my paper is graph paper? Okay, I'll remember that when I'm grading your test next time.
I did not say it. I think it's beautiful. I'm actually really impressed. Wait, when are we going to have our next test?
I can tell you later. Okay, so we're going to talk about the 2 different equations and what we need to memorize for those equations. Yes, Ryan?
Shouldn't we be doing something special because it's Pi Day today? So we should like have a...
You should have brought me a pie, and then maybe we would have done something special. Okay, so y equals a times the quantity of x minus h squared plus k. So you all tell me, is this an equation of a vertical parabola or a horizontal parabola? Vertical. This is a vertical parabola. All right, so a couple things we need to, or not a couple, a few things we need to memorize. Right, our axis of symmetry. All right, because it's a vertical parabola, the axis of symmetry will be a vertical line, and it will be represented by the equation x equals h. Yep. All right, the vertex. The vertex is going to be represented by the coordinates h comma k. Our focus. Right, our focus is going to be represented by h comma, and then we're going to take k and add it with 1 over 4a. That a is in the denominator. So it's k plus 1 over 4a. The a is in the denominator. All right, we're going to keep going. The directrix. So now we know, I can't have side conversations. So we know that the focus is a point. The directrix is what? Focus is a point, the directrix, Matt, is a line. The focus is a point, the directrix is a line. For a vertical equation, the directrix is a horizontal line. Since it's a horizontal line, is it x equals or y equals? Y equals. So it's going to be y equals k minus 1 over 4a. That a, once again, is in the denominator. That's the equation of the directrix. Yes?
There's like k and h. Do you include the sign that's given?
Yes. Okay, so now we're going to go here, letter E, direction of opening. We know if A is greater than 0, we are going to open up. We know if A is less than 0, we're going to open down. And last but not least, we have the length of the lattice rectum.
What's funny, Kenny?
What's so funny?
Okay, so it is the absolute value of 1 over A units long. Why do you think I'm saying the absolute value? Because length can never be negative, exactly. Okay, so that's everything for the vertical equation. Now let's talk about all the different formulas for the horizontal parabola. Do you think you need to memorize all of these? Yeah, this is why this unit is the worst. Okay, so now we want x is equal to a times the quantity of y minus k squared plus h. We know this is going to be a horizontal parabola. Right, and all of our different equations. So the first one we're going to talk about is our axis of symmetry. Now our axis of symmetry, since this is a horizontal parabola, the axis of symmetry should also be a horizontal line. A horizontal line is that x equals or y equals? Y equals. So it's going to be y equals k is the equation of our axis of symmetry line. All right, vertex is the same. Vertex is going to be h comma k. All right, our focus point is going to be h plus 1 over 4a. That a is in the denominator, comma k. Their directrix is going to be the line. This is now going to be a vertical line, so x equals h minus 1 over 4a. Again, the a is in that denominator. All right, now the direction of the opening. So if a is greater than 0, it's going to open to the right. If a is less than 0, it will open to the left. And lastly, we have the length of the lattice rectum. Is still going to be 1 over a, the absolute value of 1 over a units. All right, so we need graph paper. Does anybody need graph paper from me, or you guys still have from last time? You need graph paper from me? Oh no, where did the graph paper end last time?
Wait, how about we don't have graphics? I always say don't do it like that.
I have graph paper, so I can do that.
Draw your own graph.
Yeah, you can draw your own graph. Don't worry, I ordered a whole bunch of graph paper this year.
You'd rather snap it than
Come on. Don't keep your arms
Let's figure it out.
I don't think that's a good idea.
Me too.
I feel that shit.
I'm gonna get a 50 on this.
I didn't like
There is other things to do, but I'm gonna say very sugar. But I'm gonna get a 50 on my teacher. Like, everything was like hardly all of it sounds small.
All right, graph paper is going around if you need it. If you don't Joan, if you have from last time, just pass it along. I'm going to get started. Once I get my pen.
I like.
Okay, so now we are going to sketch. No, well, not actually, it's not sketch. We are finally graphing. We are finally accurately graphing, not just coming up with a hard, with a rough estimate sketch. So I want us to graph y equals 1 over 8 times the quantity of x minus 1 squared plus 4. All right, so our two options are vertical parabola versus horizontal parabola. Right, this is a vertical parabola. Someone tell me, how do I know that this is a vertical parabola and not a horizontal parabola? Arish. Because it's y equals. So we're going to say this is a a vertical parabola. And we know the format in vertex form of a vertical parabola is 1 over, not 1 over a times the quantity of x minus h squared plus k. Let's just list everything out for us. Do we all agree our a is 1 over 8? Right? What is h? It's not negative 1. Positive 1. All right, and what is k? Positive 4. All right, what is it that I want? First thing I want is the vertex, and we learned from our formula page that our vertex, isn't it h comma k? So our vertex is going to be the point 1, 4. You got it. Then I'm going to go on, and I want to find the axis of symmetry. And if you guys remember, the axis of symmetry for a vertical parabola was going to be x equals h. It's going to be a vertical line. So this axis of symmetry is going to be x equals 1. We're going to keep going. I'm going to now ask about the direction of the opening. Because A is positive, are we opening up or are we opening down? Up. If I'm going too fast, just tell me to slow down. All right, now I want our focus. So I need the coordinates for our focal point. And if you all remember from the last page, because this is a vertical parabola, it's going to be h comma k plus 1 over 4a. So now let's plug this in. So our h is 1, so we're 1 comma. Our k is 4 plus 1 over a. Well, what's our a? 1/8. What's 1 divided by 1/8? 8. So this becomes 4 plus 8, which is? Oh, I just did 1/8. It's 4a. Sorry, guys. It's 4 times a. I just did the a. So then 4 times 1/8 is 2, right? 1/2. So now we're 1 over 1/2, which is 2. So then we're 1 plus 4 plus 2, which is 1/6 is our focal point. We're not done. One more. I want our directrix. Because this is a vertical parabola, the equation for our directrix is y equals k minus 1 over 4a. So for the focus, it's plus. For the directrix, it's minus. So now we plug in. We're going to have y equals, our k is 4, thank you, minus 1 over 4 times 1/8. Well, we just did this. So this is going to be 4 minus 1 over a half, but what was 1 over a half? So 4 minus 2 is 2. So this is a line, y equals 2. Now we are ready to graph. I'm going to box all of our answers here. Here we go. All right, so now we're ready to graph. All right, I'm going to start off with my vertex. My vertex was the point 1, 4, so over 1, up 4. I'm going to put a V there for vertex, just so I know. Oh, what have I not found that I should have found? The x and y intercepts. I did not find the x and y intercept. So, looking at our vertex point, the fact that it's all the way up here, is there going to be an x-intercept? How do I know there's not going to be an x-intercept? Aditya. Good. The parabola is, its opening is up, right? So since the opening is up, there's no way we're going to hit that x-axis. So we know right away the x-intercept is none. Will there be a y-intercept? Absolutely. So for the y-intercept, we're going to set x equal to 0. So I'm going back to the original equation. Y equals 1/8 times 0 minus 1 squared plus 4. So y will equal 1/8, because 1 squared is just 1, right? Plus 4. So now I would say change it to an improper fraction, but when we're graphing, isn't mixed numbers easier to deal with? So what is this? 4 and 1/8. Yes, David.
Isn't there a 1 in there because negative 1 squared?
Yeah, and what's 1 times 1/8? 1/8, right? Tejas.
How do you know the x-intercept is 9?
So, what kind of parabola do we have?
One that's facing up.
It's a vertical parabola, right? That's opening up because the A is positive. So if this is our vertex, meaning that's our turning point, and it's opening up, is there any way we're going to touch down here? That's how we knew. Okay, so now we have our x and y intercept. So this is the point 0, 4 and 1/8. So we are 1, 2, 3, 1, 2, 3, 4. Oh, and then 1/8 is up here. So we're somewhere up there. Okay, so now, oops, actually, I'm not going to do this just yet. I'm going to plot everything else. So we got our y-intercept. Now the next thing I want to plot is, let's just go in order. We'll plot our axis of symmetry. We always plot the axis of symmetry as a dashed line, because it's not really part of the graph. So that is the equation x equals 1 is our axis of symmetry. So I'm labeling it all for you. All right, so now let's plot our focal point. So our focus is 1, 6. So over 1, up 6. 1, 2, 3, 4, 5, 6. I'll put F for our focus. And then we'll plot the directrix. What was our directrix? Y equals 2. That's a horizontal line. 1, 2. It can go either way. I think I make it solid. I'm going to double check that for you guys though. Okay, so then what do we have? We have our focus, we have our directrix, we have our y-intercept. The last thing I need, oh, that I didn't find out. No, we have the focus. The latus rectum. Why is the latus rectum important? It's going to tell us how wide this parabola is going to be. It's going to tell us how wide this parabola is going to be. So I did forget that. Let's go back here and find that latus rectum. Okay, so this is the length of the lattice rectum. It's going to be the absolute value of 1 over A units. So guys, tell me, this is 1 over 1/8, which is 8 units. So what does that tell us? It's going to be pretty wide. So if the A is a fraction, is it going to be wider or more narrow? Wider. If the A is a whole number, is it going to be wider or more narrow? More narrow. It's actually the opposite of what you would think. Okay, so if it's a fraction, it's going to be wider. If it's a whole number, it's going to be more narrow. So now let's go through and plot that. So remember, this is 8 units, but what does that 8 units represent? Well, the lattice rectum goes through the focus and is perpendicular to the axis of symmetry. So here's my focus, here's my axis of symmetry, so I'm coming right horizontal through that focus point. My total length for the lattice rectum is 8. What does that mean? 4 units to the left and 4 units to the right of the focus. That gives us that total length of 8. So we're going to go focus, 4 units to the left, 1, 2, 3, 4. Focus, 4 units to the right, 1, 2, 3, 4. And now we plot. Now we connect. No, we don't draw a line. That's just determining how wide our parabola is. It's not an equation of a line. Oops. Huh? So it looks something like that. Huh? I don't know. I could tell you on review day when I make it up. Okay, we ready for the next one? Sure.
So, you just find the focus, and then since they're on the same line, it's easy to see the distance between the focus and the vertex, and then go the other way to find the directrix.
Yes, but at some point I'm going to ask you for the equation of the directrix, which means you need to know the formula. But yeah, you're right. And sometimes it's not going to be such a nice number. Sometimes there might, be something sloppier in it. But absolutely, that's the whole point of a parabola, right? It's the same distance away. Okay, let's keep going. Let's do another one. I'm going to do a horizontal one now. Why? They're the same to me. I haven't gotten to the bad ones. Okay, so I think the bad ones are all in your homework. It's just because it's more decimals. That's the only thing. Okay, so right now I cannot start graphing this. Why can't I start graphing this? Good, there's a 6 by the x, so what should I do with that 6? Divide it under everything. Now, tell me, I don't want to leave it as the quantity of y minus 3 squared over 6, because I want that over 6 to be considered what, Aditya? We want it to be our a. So we're going to pull that out as a 1/6 times the quantity of y minus 3 squared plus 5. All right, can someone tell me, how do we know this is a horizontal parabola and not a vertical parabola? Good, because it's x equals, it's not y equals. So this is a horizontal parabola. And because it's a horizontal parabola, it should be x equals a times the quantity of y minus k squared plus h. So let's list out everything we know. We know our a is 1/6. Because our a is a fraction, is this parabola going to be wider or more narrow? Wider. What if it was 6? Then it would be more narrow. Good. So our A is 1/6. Our H is not 3. What's our H this time? 5. Very good. And our K is 3. All right, so we're going to find everything we found before. Let's start with our vertex. All right, our vertex is still HK, so that is going to be 5, 3. You got it. All right, our axis of symmetry. Because our parabola is horizontal, our axis of symmetry will be horizontal. So it's not going to be x equals this time, it's y equals k, which is 3. All right, let's get our focus. Hey, our focus is going to be h comma k plus 1 over 4a. So we are 5 comma 3 plus 1 over 4 times 1/6. Did I mix it up?
Yeah. It's supposed to be H plus 1.
Oh, this is a horizontal one. Sorry, guys. It's a horizontal one. H plus 1 over 4a comma k. Because it's horizontal, it goes with the H. So then we're going to put 5 plus 1 over 4 times 1/6, comma 3. I'm going to simplify that down. We are 5 plus 1 2/3, yes, 2/3, comma 3. And then we're going to have 5 plus 3/2. But what's 3/2? 1.5. So what is that going to be? 6.5, comma 3. You can, but we're going to plot it. So for me, always plotting decimals or mixed numbers is easier to visualize than an improper, but you can leave it as whatever you want to leave it as. Are you not supposed to know? You can if it makes it easier. Generally speaking, all our answers in algebra are improper fractions. But when we're plotting, it's a lot easier to visualize plotting a decimal or a mixed number versus an improper fraction. That's why I always change it. All right, next one, directrix. All right, directrix. It is a vertical line, right? It is a vertical line, the directrix. Yep, so it's a vertical line, so it's going to be x equals, and then we have h minus 1 over 4a, because remember, the focus is plus, the directrix is minus. All right, length of lattice rectum.
Is it the same as last time?
Yeah. So no matter what, whether it's vertical or horizontal, it's 1 over a units long. So this is going to be 1 over 1/6, which is 6 units. And remember, what does that 6 units mean? 3 to the left of the focus point and 3 to the right of the focus point. All right, let's get a rough sketch, or let's start our graph to see about the intercepts. We might have intercepts, we might not, but we'll definitely know once we plot at least the vertex. So what was our vertex? I don't remember. 5, 3 was our vertex? Okay. And then are we going to open to the left or to the right? To the right, which means, what does that mean? It's going this way, something like that. Don't draw that. But doesn't that mean since A was positive? So are we going to have a y-intercept? No. So y-intercept, none. X-intercept, what are we going to do? plug in 0 for y. 6x equals y, 0 minus 3 squared plus 30. So we have 6x is equal to 9 plus 30. So we have 6x is equal to 39, divide by 6. We have x is equal to 13 halves, which is 6.5. So the x-intercept is 6.5 comma 0. Okay, let's plot everything else. So this was our vertex. Let me go put it V. All right, let's plot our focus. What is our focus? 6.53. And then we want our directrix. Our directrix was x equals 3.5. Our axis of symmetry is a horizontal line right through the vertex. And the last thing I want is our length of our lattice rectum, right? So I'm going to go to the focus. Everybody always wants to go to the vertex. No. You go to your focus. There's our focus point. And then what we're going to do is we're going to go 6 units? Yeah, so 3 units above, 1, 2, 3. And then 3 units below, 1, 2, 3, which is the x-intercept. And then you connect those points. So if you memorize the formulas, it's not hard. It's just more tedious than anything else. I want you to try one on your own. Here, you guys try this one. So my first question for you, is it vertical or horizontal? Vertical. The other question for you is, how do I put this in the vertex form? Dylan? No. It's already squared. We're good. Y equals, there you go, 2 times the quantity of x minus 0 squared minus 1. And if there's something squared there, generally speaking, unless it's like 2x squared plus 5x plus 7, where there's like another x, then that's when you'd want to complete the square. But since there's not that x term, generally you can manipulate this. You're doing it on your own. And then someone can come up if they want to sketch it. Somebody with neat handwriting.
I can sketch.
We got Jason.
I don't like
Simon wants to do it.
I like it much better teaching in the morning.
I don't. It's like weird. We like teaching in the morning.
Yeah.
You don't do it.
I just sat around here and
You don't have an afternoon class?
I have one afternoon class.
Oh, that's so nice.
Is it CS class?
Alright, you guys want to know when your test is?
Yeah.
Maybe in July.
No, we're gonna have one now.
GPA's already finished. Where's the market period?
It's gonna be Monday. Because you drop tomorrow, Thursday's transformations and absolute values, which we've already done. And then review Friday, test Monday. How many tests have we had this marking period? This would be our fourth. This is our last test for the marking period. This is the last test for the marking period.
There's just 2 weeks of nothing.
No. The test goes to the next marking period, exactly.
So we're going to have chapter 14. Oh, chapter 13.
Chapter 13 will be the first grade of the fourth marking period.
But it'll be before spring break.
But I'm going to try to get it in before spring break. I'm going to try my best. I don't know if I will. Right now, it's looking pretty close. Like if we have one snow day or if I'm absent one day, it's not going to come in.
Wait, if it's after, then can we get a curve?
No. There'll be no curve. You'll just be at a huge disadvantage.
What?
Because we forget everything.
Can we get another review day?
Yeah, I'd give you another review day.
You don't do anything.
I'm still gonna fail. Yeah, but I mean, we don't do work. Yeah, I think that's directly. Okay. Oh, no, mine is ballistic out there. I got it. John, where are you going this week? Where are you going this week? You know it? You know it? I mean,
I'm sorry? So the only thing you're missing, well, you know your y-intercept. Where's your x-intercept?
Oh wait, I think I know what I did. Can I just like, cause I know what I did wrong. There has to be. So it's gonna be like square root of 2 over 2, right?
Square root of 2 over 2.
Because
Yeah. Mhm.
So then
you have to estimate that.
Estimate between the square root of 1 and square root of 4 was it's like kind of like 1.2, I want to say, like somewhere around there, because it's between square root of 1, which is 1, and the square root of 4, which is 2.
So it's like sort of halfway between those, right?
It's like 1.5.
Mhm.
So the x-intercept on both sides would be like 1.
So that it would be 1 over 5 over 5. I mean over 2.
That's 0.75.
Yeah.
It's like 3/4. That is.
You got it.
That's so tiny.
Yeah, very tiny.
I can't. We're just gonna say that's 3/4 and move on.
Okay. There you go. Okay, guys. Does anybody want to come up and teach us this? Yes? Simon. Because I didn't pick him yet. Because I didn't pick him last time and he was so upset at me. So I picked him this time.
Simon doesn't deserve those. Simon's handwriting is shame. This phone too.
You all have pretty bad.
Simon's handwriting is an atrocity.
Matt's been talking too much.
And he's a lefty.
Oh, lefties are always.
How do I draw on this?
Oh, look, I'm too short for him. Look, he has to bend over my trivia.
How do you deal with this?
Just raise it for you. Just raise it.
No, over. Under.
What are you talking about?
Is he qualified to be a teacher?
Oh, this. Okay. Perfect.
No, you have
Where's
to
all the
solve
word
everything
numbers?
first.
No, just draw it.
He told you to I like it.
Simon, draw a straight line.
Trust the process.
But you see, it's not that easy.
It's not.
It's not that easy. So when I mess up my points and you all laugh at me,
Solve it.
Bro,
You have to show your
bro,
work.
homie, trust the process.
y'all are being so rude to Simon.
I'm just saying, trust the process.
I like Simon, but I like Matt a little.
You know what he said?
Wow.
Came out of left field.
You like Matt sliding all the way.
Yeah, okay.
Simon's gonna take that.
Simon, how do you feel? How do you feel?
Do I have to like show how I got my x-intercepts, or can I just like say that?
You gotta teach them.
Shouldn't have come from
Does anybody know how to remove whiteouts off of someone's nails?
Why is there whiteout?
Your fault. You drew pen on my paper.
Well, it's your fault.
So you
whited
whited
it
it
out. Using whiteout. That's on you.
Who uses whiteout?
No,
She was just yelling at Ryan, and Ryan didn't even flinch. He
Yeah,
didn't
Ryan-
even look in her direction as if she weren't even just scolding him.
Bro, Ryan.
He didn't even flinch.
It's because Ryan is he's just not good.
Bro,
Ryan,
he's
yeah,
too good.
I'm just crazy right
Where's the
I'll write it. Give me a second.
What is that?
Give me a second.
You realize you're supposed to be teaching everybody.
Yes. Okay, guys.
explain?
So
Look,
you
if
see,
people are erasing and fixing their work.
H is 0, K is -1, which is why the vertex
Write
is
that down.
down 1,
What's
right?
your A?
Notes, everybody, notes.
And the x-intercept plus or minus √2/2. It's just the square root of 1/2, you know. So I drew those.
How did you estimate the square root?
So actually, that's a good question. So I know, like, for the first 2 points, you're gonna go up by left one up 2 and right one up 2. So they have to be between 1 and 2, or 0 and 1. Between 0 and 1, right?
That's fair.
So I kind of just like put a point between 0 and 1.
Okay, so his thinking was absolutely correct. Let's say you wanted to actually estimate what this would look like. So it was the point √2/2, comma 0. We need to estimate that. So what you're going to do is you're going to estimate the radicals. So you pick the two closest perfect squares, which is √1 and √4, right? Square root of 1 is 1. Square root of 4 is 2. Aren't we going to be right between 1 and 2? So I'm estimating this as 1.5. Just guessing, okay? And then we're going to do 1.5 divided by 2, which is approximately 0.75, which is right around where Simon was saying. Yes?
When you're estimating, you go off of the square root of the two numbers to get like the middle. So like you'd go off of 1 and 2, and then use the square root of 2 to find the.
Okay, guys. Well, David's talking.
Yeah, so like, let's say it was √3. √3 would be closer to 4 than it would be to 1. But √2 is like right at 2 is right in the middle of 1 and 4.
Oh, okay.
So that's why I chose a number right in the middle of their two perfect roots. But if it were √3, then we'd be closer to 4. So then I would have done like 1.8 or 1.
Yes, Dravid?
Was it minus or not?
I thought it was plus.
No,
It's-
as long as you're estimating around there.
Okay, directrix. Whoopsie doo guy. Wait.
Oh, wait, no.
Wait. You're welcome.
We got it wrong?
No, listen. Okay, there we go, guys. Right? So -7/8. It's just the focus in the directrix is just 1/4a plus the vertex and minus the vertex. So it's just like, you know. So like,
So he's just saying we're gonna be an equal distance away. That's what he's saying.
yeah. So it's like, yeah. So pretend that distance between one, like this is like 1/8.
Like really fast.
So that would
Why'd
be
you draw a line there?
because it's the directrix.
You didn't tell us that.
No, that's the focus.
It's literally right.
The direction is when you line it.
The focus is the point. What is Chris talking
Yeah, you
about?
drew a line. You drew
That's the directrix. The focus is the point
Right?
above it.
And then,
Oh wait, no, that's
No, he's okay. He's
yeah,
okay.
I'm okay.
The focus is above it.
Wait, so then this is 1/8 plus 1 is 9/8. So this is like y = 9/8.
You're in
Or is it x equals? No, y
Y
equals.
equals negative 9 over 8.
Yeah.
Yep.
There's just 1 over 8 less than the minus 1, and then
Yeah.
the focus is just minus 7, 8,
Yes.
which is what I wrote there. And then the lattice rectum is just
Those
1.
two.
Okay, yeah, I'll write that. So lattice rectum 1 over a equals just 1 over 2. Can I just like say that? Is that okay?
Yeah.
Okay, which means the distance between here and here is 1 over 4.
Yeah.
But I don't know how to write that. It's too
No,
small.
you're fine.
Okay. 1 over 4.
So what he just did lastly with the lattice rectum, he got as the is going to be a half. What does that mean? From the focal point, you're 1/4 unit to the left, 1/4 unit to the right. Obviously, that's a complete estimation. There's no way to be completely accurate with that. Okay, so last thing we want to discuss, which we've already been discussing this whole time, is if A is, or the absolute value of A, we should say, is greater than 0. If the absolute value of A is greater than 0, which means it's a whole number, right? Are we going to shrink, or are we going to be wider? More narrow or wider? Shrink, right? It's not a fraction. So if we're greater than 0, we're not a fraction, where A is a whole number. So this is going to shrink or be more narrow. And if the absolute value of A is, it shouldn't be 0, I should have put 1, is less than 1. If the absolute value of A is less than 1, but obviously it's not going to be negative because it's the absolute value, that means we're just dealing with the fractions, right? What does that mean? Are we going to be wider, or are we going to shrink? Wider. So the parabola is going to stretch, and it's going to be wider. All right, so there's going to be a whole section, and this is all in reference to the parent function. It's all in reference to the parent function. And remember, the parent function for a parabola is centered, or a vertex, at 0, 0. All right, so there's going to be a whole section like this on your test where I ask you to describe the width.
Is it big or small?
Compared to y equals x squared, our parent function. All right, so here I'm going to have 4 times the quantity of y minus 2 equals x minus 4 squared. All right, what I have to first do is put it in the correct format. Is this going to be x equals or y equals? Y equals, because the x is what's being squared. So that's how I know it's going to be a y equals. So the first thing I'm going to do is I could divide by 4 on both sides. So then I'm going to have y equals 1/4 times the quantity of x minus 4 squared. Oh, sorry, no. So this is y minus 2. And then what should I do? Add the 2 over. Y equals 1/4 times the quantity of x minus 4 squared plus 2. All right, so now what we're going to look at is we're going to look at the A. Basically, to sum this up, if your A is a fraction, it's going to be wider. If your A is an integer, it's going to be more narrow. Since our A is a fraction, what's it going to be? Wider. So when it says describe the width is wider. Let's do a couple more. Sure we do. Okay. Right here. I'm doing one more. Y equals 3x squared plus 1. Isn't this the same as y equals 3 times the quantity of x minus 0 squared plus 1? All right, so my A is a whole number, so are we going to be wider or more narrow? It's going to be more narrow. All right, we are done.